Welcome back to our discussion about the unit circle. So we finished up the last video and we talked about really kind of what the unit circle was, just a special kind of circle that had different angle measures on it. And in this video, we're going to really dive in a little bit deeper and become familiar with what exactly is on a typical unit circle. Now, it's really important that you don't just recognize what's important or what's on the unit circle, but really know it, memorize it, become intimate with it. Because when you're familiar with the common angles on the unit circle, it makes identifying their trig functions just as easy as, oh, I had to just do something kind of silly because that's, yeah, okay, it's easy as pie. All right, okay, let's go back to math. Okay, so here is the most commonly used unit circle with nothing filled in. Okay, so we're going to talk through what is important to know here. Notice that, let's just put our attention to that first quadrant. In our first quadrant here, we've got the quadrantal angles of 0 degrees and 90 degrees, but there are also 3 spokes on this unit circle. Okay, and so this one is going to be 30 degrees, this one is 45 degrees, and this one is 60 degrees. And you'll notice that in each of the quadrants, you're going to have those same types of angles. Everything here is going to be 30 degrees. So this is going to be a 30-degree angle. This one's going to be a 30-degree angle, right? This one's going to be a 30-degree angle, and this one's going to be a 30-degree angle. But they're not exactly just 30 degrees, right? These are multiples of 30 degrees all the way around the circle. So if I were to fill these in, I'd go from 0 to 30, and I'd skip that middle one because that's a 45. 60 degrees, 90 degrees, 120 degrees, skip that middle one. 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, all the way around. And then these ones in the middle are multiples of 45. So we would have 45 degrees, and we would skip up here to 90 degrees, and then the next one would be 135 degrees, and the next one would be 180 degrees, 225 degrees, 270 degrees, and 315 degrees. And then all the way back around to 360 degrees. So those are the basic angle measures in degrees that are on a base unit circle. Now, you would want to know the corresponding radian measures of each of these, and I want you to remember that anytime we have a 30-degree angle, these are going to be pi over 6's. So this is going to be a pi over 6, this is going to be a pi over 6, this is going to be a pi over 6, and this is going to be a pi over 6. Okay, so when we fill these in, you'll see that these are multiples of pi over 6. These are pi over 4, right? Because 45 degrees out of 180 degrees is 1/4 of pi. And these 60-degree angles are going to be pi over 3. Again, 60 degrees divided by 180 degrees is 1/3 of pi. So you can just memorize those. But let's go ahead and count through, okay? Now, we did kind of count through on your degrees with 30s. And I would like to show you how to do that with your radian measures, okay? Because if we go all the way around and land on those 30-degree angles, we should just be adding pi over 6 every time. So pi over 6, and this is 2 pi over 6. But that simplifies to pi over 3. And now this is 3 pi over 6, which simplifies to pi over 2. And 4 pi over 6, simplifying to 2 pi over 3, 5 pi over 6. 6 pi over 6, again, simplifies to pi. 7 pi over 6, 8 pi over 6, which simplifies. 9 pi over 6, which also simplifies. 10 pi over 6, which also simplifies, and 11 pi over 6. Okay, so all of those that are not those middle spokes are going to be pi over 6, but they can actually simplify to pi over 3 if they're multiples of 60 as well. Now those ones in the middle, these are pi over 4s. And again, we can count by pi over 4. So just count by pi over 4 all the way around. So we'll start here, 1 pi over 4, 2 pi over 4, simplification, right? 3 pi over 4, 4 pi over 4, another simplification, 5 pi over 4, 6 pi over 4, simplification, 7 pi over 4, and 8 pi over 4. All right. So that gives us the angle measures that you should be familiar with on that unit circle. Now, you should know your x and y coordinates for each of these, all right? So these all come from just knowing your basic special right triangles, a 30-degree right triangle, or a 30, 60, 90-degree right triangle, or a 45, 45, 90 right triangle. So let's just focus in our first quadrant here for a second. We definitely know if this is a circle with a radius of 1, that the coordinate here would be 1, 0. And we definitely know that the coordinate here would be 0, 1, because this is the origin. Then the rest of these, notice that I could think of this as a right triangle with a 30-degree angle. Now, if that is true, and I know this is a radius of 1, I can use the Pythagorean theorem to derive, or my trig ratios to derive these. And we would end up with rad 3 over 2, comma 1/2. Our 45, 45, or 45, 45, 90 triangle, our 45-degree angle on the unit circle will have a coordinate of rad 2 over 2, comma rad 2 over 2, and our 60-degree angle will have a coordinate of 1/2, comma rad 3 over 2. Now, the rest of the unit circle, once you have this first quadrant memorized, you can just use reflections to get the other pieces. These coordinates here are the same. They're just a reflection, right? And we'll have negative x, positive y in that first or second quadrant, sorry. And we will have negative, negative, negative x, negative y in the third quadrant. In the fourth quadrant, we'll have positive x and negative y, but they're all reflections. So memorize those. Then I would suggest, it's not required, but I would suggest taking the time to memorize the tangents for each of these. It doesn't take that much longer because, again, you really only have 3 types of angles. So if you know those, I didn't really tell you that the whole reason to memorize these is because they give you your sine and cosine, right? Y is sine and x is cosine for each of these angle measures. So remember that you can find a tangent by taking the ratio of sine over cosine. So in each of these cases, if I divide y by x, I would get my tangent. And notice that each of those 30-degree angles have a tangent of rad 3 over 3, either positive or negative. Each of the 60-degree angles has a tangent of rad 3, either positive or negative. And each of those 45-degree angles has a tangent of 1, either positive or negative. Your quadrantal angles on the xy axis will either be undefined or 0, depending on what the coordinate is in the denominator. Okay, so take some time and memorize the unit circle. Now, and I would say go ahead and practice with your unit circle in front of you, but take some time to work on memorizing it so that it becomes very familiar to you. So so now the whole reason we want to know our unit circle is because we want to be able to quickly evaluate trig functions. Remember I made that corny lame joke at the beginning because it makes it easy as pi? It really does. Okay, so if I want to evaluate the sine of 4 pi over 3, the first thing I want to do is find the coordinate that corresponds to the angle measuring 4 pi over 3. Okay, so I'm coming on my unit circle, I'm finding 4 pi over 3, and I'm identifying the coordinate. Okay, so my coordinate is -1/2 -3 over 2. And now I'm remembering that sine is the same as the y coordinate. And so I am just going to identify the y value of that coordinate, which is -3 over 2, and I'm done. See how easy that was? Let's try another one. Oh, cosecant of 7 pi over 6. Again, find that angle measure, 7 pi over 6, and find the coordinate that corresponds to it. So here's 7 pi over 6, and here's the coordinate, okay? So here's my coordinate, and I am interested in cosecant. And cosecant, remember, is the reciprocal of sine. So I'm going to take that y value and take the reciprocal of the y value, and that will be the cosecant there. And so that reciprocal will be -2. All right, cosine of pi over 2. Let's find pi over 2. And then the cosine is always going to be the x value. So I can just look at my coordinate, find the x value, and there we go. It's 0. How about the tangent of 11 pi over 6? Now, if you've gone and labeled your unit circle a tangent, that makes it easy because we're coming over to 11 pi over 6, and we're just grabbing that tangent value. Remember, y is sine, x is cosine, and tangent is the ratio of sine over cosine. So our tangent for 11 pi over 6 is -3 over 2. Our secant of 2 pi over 3. Okay, let's find 2 pi over 3. All right, 2 pi over 3. Where's 2 pi over 3? All right, there it is. Find that coordinate, -1/2 square root of 3 over 2. And secant is the reciprocal of cosine. So cosine is x, and so x is -1/2, and our reciprocal will be -2. How about cosine of pi over 3? Can you do this one? Try it out. I'll wait for a second. Come on back. Find pi over 3. Oh, here's pi over 3. And the cosine is the x value, so we should end up with just 1/2. And last one is cotangent of pi. A little bit tricky, but not too bad. Okay, so find pi and find the tangent, and then take the reciprocal of the tangent. Okay, here's pi, here's our tangent, and the reciprocal of tangent, oh, that puts the 0 or in the denominator, so that's going to make our cotangent undefined. When we return, we'll talk about how we can use the unit circle to derive domain and range of our sine function and cosine function. See you then.